In this example, we're going to look at using constants and enumerations. Constants and enumerations are basically C# programming constructs that make your code easier to understand and easier to maintain. So let's take a look at what we mean by that. Suppose we had some code that looked like this. So we have some if statement and we've got some variable and we're comparing it to the constant number 32. And if that condition evaluates to true, then some code is going to run. The problem is this is a bad practice. First of all, what does 32 even mean? I mean, if I'm a programmer and I'm writing the code, I might know what it means, but 2 years from now, I might not know what it means. Somebody who has to look at my code must probably have no idea what that means. Worse yet, what if it changes in the future? If I'm using this 32 value all over my program, I'm going to have to change it if for some reason in the future that 32 is no longer applicable and the test needs to test for some other number. Well, the way that we fix this problem is by using constants and enumerations. So we can write the same thing by writing if some var is equal to freezing, then the code runs. That's much better. It's clear what the code is trying to do. It's testing for some freezing value of some liquid. And if we ever decide to switch it, we just change the constant definition in one place. And the way you define that constant freezing is by using the const structure. So here I'm saying const, and then the int, and then the name of the constant that I want to use is equal to some number. So constants are used for numbers whose value is not going to change over the life of the program. So here you can see I've got a definition for const int freezing equals to 32. That's the freezing point of water. The freezing point of water is very unlikely to change in the future, so therefore I define a constant for it. So if I want to change this constant to something else in the future, or change it to some other definition, I just do it in one place, and the rest of my code just picks up the change, and people reading my code in the future know what that means. Enumerations are a close cousin to constants. And what you'll probably find in many situations is that you'll use a whole bunch of constants that are related to each other. For example, if we had a constant for the freezing point of water, we might have a whole bunch of other constants to go along with it. There might be one for lukewarm and for hot and for boiling. Well, it seems kind of silly to have all these separate constants defined for different values that are really all related. So the way you solve that problem is using what's called an enumeration. In this case, we can build what's called an enumeration for temperatures, and we just simply group them all together. So for example, we would group the value of freezing and lukewarm and hot and boiling all into one enumeration. This way, if we wanted to add a new one in the future, like say we wanted to add one for room temperature, all we would do is make room for it in the enumeration, add the value for it, and then we're done. So now we have a whole bunch of temperatures that are grouped together logically instead of having a whole bunch of different const int definitions. Enumerations start off by 0 by default if there's no value assignment. So for example, if we have our temperatures enumeration and we put something at the front of it, like say really cold, that's going to default to the value of 0 unless you explicitly assign a value to it. So to build an enumeration, you simply have the values that you want to assign to words, which are easy to read, and if you don't assign it, then it defaults to 0. If you also don't make a definition after one that's already been defined, then that defaults to one more than whatever the previous definition was. So for example, if we were to put another definition in here right after freezing, which would be, say, just barely above freezing, and we didn't put an equal sign, then it would default to the value of 33 in this case. Now, enumerations by default are integer types, but you can specify other types if you want to. Now, we'll learn a little bit more about types in the next section, but just bear with me here for a second. So if we have temperatures and we have all of these values assigned to our temperature enumeration, those default to integers. But if I wanted to, say, assign them to the value of a byte in order to save space in my program for some reason, then I could put a colon there and the name of the type that I want the temperature enumeration to be. So for example, in this case, if I know the value is never going to go above 255, which is the maximum value that one byte can hold, I can just define this to be a byte. To define enumerations, you can use types that are numeric in nature, such as byte and shorts and ints and longs. And again, we'll learn what these are a little bit later in the course, but I just wanted to point this out here that you can define enumerations that are not integers by using a colon and then the type that you want the enumeration to be. So let's go ahead and jump over to the code and see some constants and enumerations in action. Here I've got my const and enums project opened in my editor, and I've got my snippets.txt file, and I've scrolled down to the constants and enumerations section. So let's go ahead and copy some code over and see how things work. So I'm going to start with these lines right here, copy those, and put them in my program right here in main. So I've now defined constants for the freezing point of water and the boiling point of water. And you can see I'm getting a little warning that says, hey, you've defined this constant, but you've never used it. So let's go ahead and fix that. I'm going to save, go back over to my snippets, and I'm going to copy this code right here. So now I've copied in some code that's going to use those constants. So here, let's scroll down a little bit. I've got an integer variable named myTemp, and I'm setting it to be 65. And then I have an if-else condition for if myTemp is greater than the freezing point and it's less than the boiling point, then we write out, hey, at this temperature, water is liquid. Otherwise, we write out, hey, water is not a liquid at this temperature. So let's save and let's run it. And we can see that at 65 degrees, water is a liquid. And if we change this to, say, 30 and run it, then we say, at this temperature, water is not a liquid. So let's do the same thing now, only using an enumeration, because you can see here I've got two different constants for freezing and boiling. Let's go back to my snippets. What I'm going to do is up here, I have an enumeration for my temperatures, and I'm going to copy that back over my program. Now I'm going to put this definition outside the main function. I'm going to put it in my class definition up here. Paste that in. So now I have an enumeration for my temperatures. So you can see here that the syntax highlighting is showing me that everything looks right. So I have an enumeration for freezing, lukewarm, room temp, hot, and boiling. Go back to my snippets. And now I'm going to use these two lines down here instead. Copy. And we'll go back to main. And what we'll do is we'll get rid of these guys. And we'll paste these in. So now you can see I'm using temperatures enumeration instead of the constants that I've got defined here. And in fact, since I'm not using them anymore, let's just get rid of them. The nice thing about enumerations is that because they're part of your program and the C# interpreter can look at them and see what they are, when you type, it will actually help you type the value out. So for example, suppose this piece of code wasn't there. I can start writing the word temperatures, and you can see that the temperatures IntelliSense is showing up right there. So I'm going to double click that, and it's going to get inserted. Then when I hit the period, you can see that it's introspecting the enumeration for me. So I can scroll down to the one that I want, and that's freezing. So I'm going to have to just do this. Bear with me for a second while I do this, because we'll learn about conversion in the future, but I have to tell the interpreter that the temperatures enumeration is an integer. And now I can say, okay, if the temperature is greater than freezing and is less than boiling, then we're doing the same thing. At this temperature, water is a liquid, or it's not. So let's change this to 65 and run it. And you can see that water is a liquid at 65. The nice thing about this is that the code here is much easier to read than having some numerical value that you don't know what it is. And in the future, if I ever wanted to, I could change these numbers up here, and I would not have to change them all over my program wherever they're being used. Just make the change in one place. So that's the argument for using constants and enumerations to make your code a lot easier to read and a lot easier to maintain.